Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this package over here. Now I ordered a lot of items from the internet and through the internet, and finally after a few months one of them is arrived. So I went to custom and I cleared this package out of custom, and let's open it and try to see what's inside of this package. So let me remove this duct tape and cut it with the help of a cardboard cutter and see what's inside of this package. So I cut the duct tape from all around the box, and as you can see there is Yoxan high quality tools. I doubt that it is a Yoxan instrument inside, but let's see, because I already asked and ordered one of Yoxan instrument, and I believe it was a soldering iron. Now, but I don't believe that this is the tool in question. So let me unbox it and see the inside of this box. Here we go. Here we go. Oh, this is the package, or the order that I ordered a test board. These 400 pin test board or pref board, whatever you want to call them, and these are, according to the seller, they are very good quality. So yeah, I believe I ordered 10 of these. This is 1, 2, 3, 4, 5, 6, and 7, 8, 9, and this is 10. Okay. And also I order a cutter, and this is a pin cutter. This is a highly professional pin cutters, in order so I can trim the legs of the parts. As you can see, it is, wow, really sharp, and from the looks of it, it is really good quality. The feel, it is good quality. Only time will tell if this is a good quality or not. And I ordered VR resistance, a 2Ks and a 1 meg. And this is a bag of transistors. I believe it was, let me just zoom into the number. I believe this is, if this camera will just focus, the 2SC 1815. So I was running low of stock of these, so these came in the right time. And now for the main reason I made this order, beside of having a pref board, this guy over here. Oh my god, this is really, yeah. Now I have a lot of analog devices, but I never own one that it is originally in this model that it was or made new by Sanwa. So if you can see, it is a Sanwa. It's an analog multimeter and the model number is YX360TRF. Now, why did I order this? Because this have a feature that none of my VOM have, and this is that feature is a drop proof, and also it is also a capacity meter. So let me remove it from this box and unwrap this and see the inside of this packaging. So I unwrap it, and they are using the same kind of bags or sticky bags that you preserve food in them, and these are really nice because these kind of bags or nylon, they don't use, and there is no need for duct tape to hold them in place. And boy, they use a lot of this. Now this is some kind of retainer foam, and this is really handy if you want to move things. This is real nice. One thing I have to say before I continue unboxing the Sanwa, the YX360TRF, is that I order this, and this is a USB programmer. So I'm going to do a video about how to use one of these and how to program microprocessors. So this is really handy stuff when you are going to program micro ICs. So yeah, stay tuned to that. Now let's back to the unboxing itself. As you can see, it is arrived in a really good neck, as I see here. No bending on the in the box itself. So real nice, really nice. I really like this. So let me try to remove this using one hand and see. This is really nice. Never owned a brand new Sanwa before. Well, I have Sanwa, but I never owned one of these new. Yeah. So what's inside of the box itself? Now, I ordered this and they said it is the original Sanwa. Now let's confirm if I got the original Sanwa or not. Oh boy and boy, how the packaging evolved. Originally, when you ship Sanwa, they have what you can spot the manual, or you can spot their manual by your if you drift your eyesight, you can you can spot their manuals, because their manuals used to have a red part of the manual, and they print Sanwa in the middle of it. But this is wow. Sanwa. And this is all what it is in the manual, no schematic. Don't believe they include schematics with their instrument. Wow. But according to this is made in Japan. So yeah, it is a lot more different from things that we see online, but I don't care. All what I care about is the device itself. And this is the device itself, and it said Sanwa, made in Japan. We hope it is what it claimed to be. So how do I remove it? Oh good God. Oh, open. As you can see here, they say open. So let me try to open it using one hand and see the practicality. Wow, another manual. Sanwa instruction manual. This is a lot more professional than that one. As we can see here, Sanwa, Japanese writing, calibration, assurance. Wow. And this is the device itself, and there is a hand ribbon that you can hold the device with it. So this is nice. And this is where the ribbon or the holder ribbon needed to be installed. Wow. The switch feels really nice to move. Yeah. And there is a battery inside of it. Wow. I love this. And this is how you use zero. I read about this online. And this is how you use zero the null. Yeah, wow. One of the features of this model, not only it can read the capacitance, it also has the capability of reading minus and plus voltages. So yeah. So let me pause this video and remove the leads from its holder and see the inside and see the leads, and open this unit and see the inside of this unit. So I removed the probes from the holder, from the plastic holder or their compartment, and as you can see they are written Sanwa on them. The only marking I found that it was a Cat 3 600 volts. So yeah, I believe these can handle 600 volt, not more than 600 volt. If we remove the caps, we unravel this gold-plated probe tip, and this is really nice. And the probe tip, it is made not very sharp, but will do the job very well. As for the protective high voltage protective cap, it is really nice, and it click really nice into its place. As for the leads themselves, they are not a very high quality like you find, or the sorry, not the quality, the thickness that you find in the Fluke or Unity, or even the Unity. They have a really high thickness, more than this. Let me grab you one of the Unity test leads, and you can notice the difference in the thickness. Let me just try to grab it. as you can see, and this is the unity, by the way, next to my VOM or the FET VOM. As you can see, this is the unity. The output diameter is about 4 millimeter, and if you confirm or you compare it, this is about 3 millimeter. So the outside diameter, it is thinner than the unity, and if I compare it to the Korean Hwang-Chang FET multimeter, you can see that the thickness of the lead, it is the same as the unity and the FET VOM. As for the Sanwa, it is less, it is about 3 millimeter. So these two are fully 4 millimeter outside diameter. As for the Sanwa, it is 3 millimeter. So yeah, this is used for low measurement current, and this will not handle any kind of current that exceed the specifications that it came with the VOM itself. But having said that, it is still a Sanwa, and I expect it to be a really high class device. Now, I already removed the cover of it, as I told you before, and now let me turn this VOM to its face and show you the inside of this VOM. So the VOM, if we turn it on its face, you will see here all the writing. It is really clear, and it is printed into the plastic in really clear, and you can feel it is done with professionalism, and it is Sanwa electronic instrument collated, made in Japan. So yeah, one thing that I have to mention when I remove the back screw, it is a metal insert. There is a metal insert inside of the plastic, and this kind, it is a nut held in screw. So this is really nice, not like the Chinese devices. They always use plastic ones, self-tappers. Self-tappers, I don't like self-tappers because they wear out the plastic over time, and especially if you did not put the screw back into its grooves right. So yeah, this is the the second thing that I liked about this multimeter. Now, if we remove the back cover, as you can see, we can see here there is an 18 ohm 2 watt resistance, and this is really good when you are working with ohm and you accidentally put it into micro ohm or into voltage. So I had a lot of accidents regarding this problem, and every time I end up blowing the resistance and the fuse. So this time they use a higher value, and that is right, and I like it very much. As for the 200 ohm resistance, and that is for the 10K or 10 multiplied by 10, they are using it as a half a watt, and there is no wrong with that. The only thing that I don't like is the way they solder and budge in the wires of the meter movement, or the leads of the meter movement or the meter works. I believe they must use a proper connection. I don't like the way they solder these they are like budged in. As for these self tappers or the nut for this screw, as you can see, it is the outside diameter is about 6.5 millimeter, and this is can stand a lot of abuse, and this is really nice, and it is brass, so thumbs up for that. As for the pot itself, the control pot, I don't like the quality of it. I believe they should use a higher grade. So let me remove one of these batteries and see what quality it is. Clearly you can see it is a Toshiba brand batteries, and it's a carbon zinc batteries. Where it is made, I don't know. This camera, and I'm out of focus, so made in China. So the batteries are made in China, but they seems to have a very good quality or a decent quality. This is the way they inserted the leads, and for this model this is okay process. So let me remove the other battery and unclip these hinges and try to remove the PC board and see how the board it is made. So here is the board has been removed from its place. As we can see, it is gold plated, and that is nice. All the diodes are 2 amperes, and they are SMD type, and we can see also a lot of high precision resistance. As you can see here, those blue ones, these are really high precision resistance, so I like this feature. Online you can see a lot of different model of this, and one of these models you can see that they are already put a hole in the PCB itself, and they use a normal kind of diodes. This is really nice because I like the way they installed these SMD ones, and they are 2 amps, so a lot more higher grade than you can find them on the internet. Yeah, but the ones that I found in internet, they have a shinier gold plated traces. These are good enough. Yeah. As for the VR resistance, like I previously show you, it is okay, not the best kind. I believe this is how they cut cost. In Japan, they don't use this kind of VR resistance. They use a higher grade, but this is what they use, and I believe it will work. As for the as you can see, if we continue to examine the PC board itself, you can see that there is a flux residue, and they did not remove this. So yeah, I don't like that whatsoever. Look at the flux residue in here, into the legs of the VR resistance, and to the pins or the fuse holders, and on the battery connectors. Yeah. As for the rotarity switch brushes, like you see here, they are not gold plated, but they will do the job, and there is a residue of a grease in them, as you can see. And you can see also in the this hinge over here, and I believe this hinge is designed to engage when you rotate, or you rotate the function key or the rotarity switch to the capacitor mode range. So yeah, all in all, it's a decent meter and I like it. Now let's do some measurement and compare it with the Unity and see how this unit will behave. So this is the Sanwa and the Unity, and I already connected them through their leads to a adjustable power supply, and I'm going now to feed it with power and see how the Sanwa will measure next to the Unity and see if there is any differences between the measurement. Now let's power it up and see what kind of voltages we should read. First of all, let me turn down the scale a little bit and see. And this is a manual range, this is an auto range, so there will be a as I boost up the power, I have to switch between these two ranges, the 10 volt and the 50 volt. So let's power it on. As we can see, it is measuring 1.2 volts on the spot. As you can see, 1.2 volts. Let's turn on the Unity. 1.2 volts plus 0, so 1.26 volts. So let me confirm, and it is right on. So the Sanwa, it is measuring the exact voltages like the digital, but because this is a 22,000 count, this is a higher resolution than this, but spot on. Yeah, you can see it. Even you can see it if I just zoom in a little bit, you can see it that it is above the 1.2. So yeah, it is right on. Yeah, it is right on. Let me boost up the voltages and see how they will align in the measurement. Now we are reading 2.9, 2.3 volts. Let me set it to 3 volts. Yep, 3 on the spot. Let me boost it up to 4 volts. On the spot, few digit off, so yeah, 5 volts. Yep, right on the spot. Wow, this is very accurate. Let me move it to 8 volts, right on the spot. Let me move it or boost it up to 9.039. Wow. And this is above the 10 volt. It is very obvious that it's 10.04846 volts, so it is right on the money. Let me flip the functions switch in order so we can measure the higher voltages. Yep, 10. So give me 12. Yep. On a 50 volt scale, so 0, 10, 20, 30, 10, 11, 12, right on the spot. Let me boost it up to 15 volts. Yep, it is lining up perfectly. So let me boost it up to, let's say, 25 volts. As we can see, it is right on the money. Let's boost it up to 30 volts. Let's say 30 volts. Right on the money. So between the Unity and the Sanwa, it is almost like a 0.25 volts at the higher range. So that is all the different voltages is. So wow. So it is really, really accurate. I love it. Actually, I love it. So, wow. Let me remove the power and test some resistance with this multimeter. So we are back, and I already set the Sanwa to measure the times 1 ohm scale, and also I zero out the Unity, and I use the real value in order so I can zero out this low range. So this is a half an ohm resistance, and let's see how the Unity will measure it. I did something wrong. I should not did. Okay. So let me pause this and untangle these. So here is the Unity. I'm going to clip one lead, as you can see, and see how it will measure it. Yep, it is a 0.03. Yeah, it's close enough. It is a 0.51 ohm. 50 ohm. Yeah, this is right. So let me clip the Sanwa. First let me see if it is zero out. It is an off calibration a little bit, as we can see. Yep, right on the 0. Yep. The same procedure like we did with the unity. As we can see, it is these dots 0.10, 0.20, 50. Yep, it is 50. 0.50, half a ohm. Right, so let's move to a higher value. This is a 1 ohm resistance. If I could grab it from the pile, let's measure it with the unity and see how well it is going and what is the real value of it. It is 1 ohm on the spot. So let's measure it with the Sanwa. One on the spot. Oh yeah. Let me switch to this one over here, and this one is a 3.3 ohm, 5%. Let's use the unity. It is a 3.27 ohm. Yeah, it is close within specs. So let's use the Sanwa. As we can see, it is this marker over here. It is 2. This is 2.5. And if this camera will just focus, I will be grateful for it. This is 3, and above the 3, between the 3 and this dot over here, you will get 3.5. So between 3.5, this is about 3.2 or 3.3. Let's measure it. Come on. Yep, it is measuring 3.5. So yeah, this is really accurate. This is not a bad at all. Yeah, and it is above. If we just zoom in a little bit, or I get even closer, you can see that it is above the 3.5 or the 2.5. So yeah, 3.5. So yeah, really nice, really nice. So let me switch to another value. Let's see what we have here. This is a 47 ohm, 5%. Let me clip it. This is the unity, how much it is going to measure with the unity. It is reading open. 46.6.7. Yep. So let's switch to the Sanwa. And this is the on the spot. This notch over here, it is 40, 42, 44, 46, 48. Yep, it is very, very close and a very, very in its specs. So wow. So let's move to a higher range, and this is a times 10. Now I'm going to switch to measure resistance from 220 ohm and higher. So this is a 220 ohm. Let me remove the it is measuring 222 ohm. Yeah. So let's see. First, let's zero out the meter and see if it is out of cal. How much did we put it? On times 10. Yep. Yeah, it is ready. Yep, on the spot. 22 multiply it with 10 equals 220. And if we just zoom in a little bit, you can see the extra digit. It is very clear. Now let's remove this resistance and get this guy over here, and this is a 390 ohm. So let me test it with the unity. 380 to 83 ohm. So it is in its specs to 5%. Let me use the Sanwa. Yep. The unity, it said it is 380 above this 380, and this is giving the above the 380. So it is really, really accurate. Wow, I must say, I'm deeply impressed. Yeah, it is really accurate. This is not some child toy or something, and something out of date, like all what you hear. This proves that all what you hear about analog, that they are rubbish and they are not accurate enough. Yeah, this is really proven that it is accurate and still be used. Now this is a 100 ohm. Let me get a 1.2 kilo ohm, and this is a 1% part, a 1.2 kilo ohm. Let me measure it with the unity. 1.2 kilo ohm, 1.21 kilo ohm, and above that. So it's a 1.22 kilo ohm. So let me measure it using the Sanwa, and let's see what kind of measurement we should get, or what kind of value we should get. We are now entering this range over here, and this is the less resolution, but as you can see, it is measuring 1.2 at the dot. Yeah, let me jump the scale a little bit, times 100, and see how it will measure it. Once again, let me zero out the meter. Click. Yep, at last. Yep. So as we saw earlier, this is according to the unity 1.22 kilo ohm. So let's see what the Sanwa have to say. As we can see here, 10, 11, 12, and above the 12 with a whisker hair. So it is giving a 12.2, and we can multiply it with 100. You can see that it is 1200 ohm, so, or close about that. So yeah, this is really close, neck to neck. This is a 22,000 count, and this is a normal analog multimeter, and it is spot on without any kind of drifting or any kind of problem. And you can measure these kind of resistance with easily with this kind of multimeter. So wow. So what we have next in the pile, this is a 5.6 ohm, kilo ohm. Let's measure it with the unity. It is a 5.557. Yeah, it is close to 5.6. So let's see what the Sanwa should read, and I'm guessing it is in here. So yep, here are measuring, it is measuring 56. Multiply it with 100 equals 5600 ohm, or even close to that. So wow, the resolution behind and the accuracy in this, it is way big, upper than I expected. Wow. Yeah. So let's jump the scale and switch it to times 1K and zero out the meter movement and measure a couple of high resistance. Yep. So I think I'm going to measure or get something a little bit higher. Let me pause this video and get something a little bit higher. So I went through my resistance box and I get 120K, 320K, and this is a 270K. So let's use the unity in order so we can measure this guy over here. This is a 120 ohm and it is giving 121.97, so it is close to 122 kilo ohm. So let's use the Sanwa. And I already connected it. It is measuring 122 on the spot. But as we can see, because it is already it has the times 1K range, the resolution it is low. So if I wanted to use this multimeter, I have to modify it in order so I can make a switch or some kind of switch that switch internally between the 1 times 1K and the time 10K. So this modification will be for a future video, but as we can see, it is really accurate. So let me measure the 330 kilo ohm. This is the unity 0.3 mega ohm. Yeah, so it is 342 kilo ohm. So let me once again use the Sanwa. And by the way, it is a very high resistance to a device like this. Yeah, as we can see, it is reading smidget about a little bit of the 200, 250, 200, 300. Yeah, poor resolution, but this is expected for something that go to this level right here. So all in all, this Sanwa, the YX360 TRF, this is really good multimeter, and it measures spot on to the unity. Of course, there is no comparison between the two. This is analog, this is digital. This has the hertz measurement, the microamp, and this is, by the way, have the 50 microamp. This one has the capacitance, the diode tester, the buzzer, you name it. And this is normal, but yeah, this is really accurate multimeter, and even neck to neck with the Unity. So I love it, and I advise everyone that who seen this video to buy this without hesitation. Wow, this is really accurate. The only thing that it is left is to do some measurement on the capacitance and see how this thing will behave, or how this thing will measure next, and compare it with the Unity. Now, according to the specification of this multimeter, this can reach up or can measure up to 10 microfarad. So this is not a very high value, but it will become very handy when you are working with something below the 10 microfarad. So let me get some capacitors and see how this thing will behave. So back in Sanwa, and as I said earlier, this time we are going to measure some capacitance. So I put it on the capacitance function, or capacitance range, and we are going to use this scale over here. Now this is a C micro, so yeah, this black scale, it is what we are going to use to measure capacitance. Now let's take a look at the manual and see how we can do some capacity measurement by using this VOM. Now this is a manual that came with it. Sanwa, over the history, it is really known for their good manual, and they use it, or they used to make manuals like a book, but now it is wrapped like a book, but it is basically a one sheet of paper, and that is not nice. I don't like that whatsoever. So measurement, range and accuracy, and if we go over here, this is the C symbol, the capacitance. It can measure a full scale value up to 10 microfarad. So when you are repairing something small like a power supply and you want to check a small range capacitor, this is handy. For higher value capacitance, you should always check it with a true capacitance meter. But if you are doing some kind of repair and this is all what you have, this is handy for small value capacitors under 10 microfarad. So let's open the manual further. Oh boy. Oh boy. And see where did they put the procedure that you should use to measure capacitance with it. Yeah. Let's try to open it with one hand. It's really difficult actually to open it with one hand. Come on. How silly is that? It is not going to open. Oh my god. This is really annoying to open this kind of manual. You have to use your both hands, so yeah. Okay, here we go. Measuring DC volt. We already done that. This is the measuring DC volt plus and minus null. We will get to that part. Measuring leakage ICU. We don't care about that. Measuring AC volts. Using high voltage probe, HV10T, using HFE probe. That's for transistors. This is really handy. Measuring ohm, we already done that. How to replace a fuse, storage, and here we go. This is the measuring capacitance C. Step 1. Set the range selector knob to C micro. Measure the capacitance by applying the test pin of the capacitor to be misunread. Yeah. After the 0 ohm adjustment is made in the same manner as in the resistance measurement. So you will have to first of all zero out the meter movement. So like we did when we measure resistance, we need to zero out the meter by shorting the leads together, but not using the ohm scale. You should zero it and adjust the needle in order so it can point directly at 10. So yeah, the pointer moves fully scale, of course, and this is the scale itself, the C micro scale, by the charging current of the capacitor. However, the pointer gradually started to return it to its original position. Read the indicated maximum value of the C microfarad scale. So it should behave like a normal capacitance, but the only if anyone try to measure capacitance with the normal VOM, you will get what we should get. Here you should get a fully range and then gradually try to drain the voltage that it has been applied to the capacitor, because the meter movement will draw it back, and then it will indicate what kind of value that it is left on the capacitor itself. So this is the idea, and this is the trick behind this. Note: be sure to short circuit both ends of the capacitor. So you need to charge up the capacitor before you do this and after you do this, because you don't want the voltages to be charged or left in the capacitor. Pay due attention to the polarity, plus and minus of the capacitor. Connect the plus side of the capacitor to the side minus of the meter. Why is that? Because this is a normal VOM, how they connect the batteries. If you take a look at the schematic online, you can see that the positive of the battery, the two AA batteries inside of them, inside of this VOM, it is connected to this lead over here, and the minus, it is connected to this lead. This is how normal VOM always work. So that's first, and I already attached the alligator clip to the probe itself. Let's try to zero out the meter works. It's really hard to do it with one hand. Yeah. So as we said, it is zeroed out at the ohm, because we already done the ohm. Now let's try to zero it out, and here you go, it is zeroed. So let's see the capacitance, and this is a couple of capacitors that I pulled them out of my collection. This is a 10 microfarad or 10 microfarad over 35 volts. This is a 15 nanofarad 100 nanofarad, and this is a 1% error. This type, it is really good. So, and this is a 10 microfarad over 25 volts. This guy over here, it is also 10 microfarad. This is a 0.15 microfarad over 50 volts, and this is a 2.2 microfarad, and this is the 1 microfarad. So let's start with the first one. This is the first 1 microfarad. As they said in the manual, the red is for the negative, and let's connect the black one, or the negative, or in this case the positive of the battery, to the positive of the capacitor. As we can see here, it is declining like they said, but it is not giving the right value. So what the heck? So what? Do we have a bad capacitor? No, it's not. It's the same. Let me use the unity and check this capacitor and see why it is behaving like it is. Positive. And the unity, it is different because it is a DAM, so the capacitance, or the black one, should be connected to the black lead of the capacitor itself. So yeah. As you can see, yep. It is a 1 microfarad, and yeah, it is within specs of the capacitor. So why this thing it is not measuring? It is not measuring. Yeah. It is not behaving like it should, or like they mention in the on the manual. This should the pointer should go to 10 microfarad and then come back to 1 and stay at 1. So this function, it is not working, or this capacitance range, it is not working. It is steady though, in 10 microfarad. This range over here, it is about about 20 microfarad. It is above the 20 microfarad. So yeah, this is not measuring capacitance right. Let me change one of these capacitors and see how this thing will behave. And this is a normal 100 microfarad. It should measure or 100 nanofarad should measure in this mark over here, 0.1. It is measuring 0. What the hell? So what they did with this VOM, I don't know, but it is not measuring capacitance. So if you are going to buy one of these capacitance Sanwa, don't hold your breath in measuring capacitance in this range. Yeah, it is not going to work. So that's a fail. So moving on to the rest of the review, and let me switch it to null and get the power supply and show you this really nice feature. So here's I got a battery. This is the one of the reliable GP alkaline batteries, and I'm not crazy about the voltage in it, but let's measure it before we do this test. As we can see here, we can set it to 10 volts. Let's measure the voltage inside of it. Yep, it is giving 9, and we should as we can see, this is the 10 scale, and we should read, because we are reading the volt on this scale over here. We can see it is 9.2, 0.4 and a half. So it is not 0.6, it is between 4 and 6. This means it is about 9.5 volts. So yeah, right. Now, one of the things that VOM lack on is the auto reverse polarity. So when you are measuring voltage like this and you have a minus voltage, so yeah, like this guy over here, you can see the needle movement on the needle work goes to the other direction. And this is, you have to reverse the polarity by your hand in order so you can test the minus voltages, whatever. But in this model, they have something it called the DC null. And that is when you switch it to this range over here, the 25 volts, you can see that there is this scale that it is set minus and plus DC volt null, and there is the 0, there is the 5, 10, 15, 15, 20, 25, whatever. So when we are measuring the DC minus and plus 25 volt, we should read the upper range. And when we are reading the minus and plus 5 volt, we should read the minus or the lower range. So first of all, when we want to apply or measure a minus and plus voltages, we need to zero out the scale, and this done by zero it by using the ohm adjustment knob. As we can see, if I rotate it with one hand, it is started to zero out. As we can see, it is zero out easily. And because we are reading 25 minus and plus 25, if we apply the leads of the probes. Let me remove the attachment, irrigator attachment, so we can use the probes freely. As we can see, it is previously we read that it is about 2.5 or 9.5 volt. So this is 5, and each one of these dots, it is a voltage. So 5, this white between the orange lines, it is the 5. And if this camera will just focus, I will be grateful for it. 10, 11, 12, 13, 14, and this is 15. So yeah, so 10, 5, 6, 7, 8, 9. Yeah, as we can see, yeah, it is 9.5. So this is really accurate. And if we reverse the polarity, it will also measure but in the opposite direction. And this is very handy when you are testing voltages, minus and plus voltages. But the problem is the higher range for this measurement on this scale is 25 volts. So yeah, but it is still a very handy feature. I wish it was 50 volts or even 100 volt. It will be really good when you are working with amplifiers, but this is how they make the multimeter itself. So this conclude or end this video. It was a very long video and I hope you enjoy it. One final word about this multimeter or VUM. It is a really good multimeter. It is built solid. It has an okay circuit board and okay traces. Not the best, but an okay traces. If you are going to use it for testing and it is suitable for testing all kind of component transistors. sorry about that. It is suitable for testing all kind of component like capacitors. No, not capacitors, because we already seen that capacitors it is out of reach of this model. Resistance, voltages, yeah, it is really nice and I really like it. But if you want or going to get this VUM for testing capacitors, you should get digital, or you should get the other model, the 506A. That model has something it called an oscillator circuit inside of it, and that circuit will be suitable more than this, designed for testing capacitor. So I hope you enjoy this video and I hope you like it. Thank you for watching. See you next time.